Right, hello everybody. Hope you guys are doing well. This is going to be the first video for the midterm review that I will post. So I will post a total of 2. So this will be part 1. I've already uploaded the blank files just like this for the midterm review part 1 onto Canvas. You can find that under Files. On the left hand side in Canvas in our course. And there is 2 parts to the midterm review. So there's a part 1 and a part 2. You will be able to see those blank PDF versions under the files right now. They've already been uploaded. I'm also going to post these filled out notes and answers after I get done with this video. So those will be posted for you as well. And the other thing I want to say, this first part goes all the way up to section 2.5. So if you have, for whatever reason, not finished all of 2.5, then I would suggest that you wait to watch this video until you've finished reading the text, at least up until 2.5. And also, if you are someone who is just using AI to get through your homework, which I really hope you're not, because I can tell you, you will not be successful in this course. I do notice the people that, are not spending any time in the learn or practice section. I can see all of that. So just so you're aware, if you haven't actually learned the material, I would suggest you go and read the text and watch the videos within the learn and do some practice before coming to watch this midterm review video, because you're not going to be able to just learn it from this video. I'm also going to be posting a formula sheet that you can use to make your flashcard that you're allowed to have for your midterm. So just a reminder, you can have a 4x6 size flashcard, only one flashcard. You're only allowed to have one. And you can have notes and formulas written on the front and the back, but you cannot have worked out examples. So if you have any questions about what you can or cannot put on your flashcard, you can always email me and let me know. And finally, before I get started, just a reminder, if you have not already made your appointment to take your midterm, that I would highly suggest you do that immediately, because their appointments fill up quickly. So if you wait to the last minute and there's no appointments available, that's on you, because I have given you announcements and reminders and all that good stuff. So make sure you get that done as soon as possible. You need to take the exam by July 13th, and it opens up next week on the 29th. So you have about 2 weeks time frame to take it, starting on the 29th. Okay, so let's get started. Now again, this is a midterm review, so all of these questions you can expect to see on your midterm. I like to give you examples and questions so that you know what to expect on your exam, so you know what to focus on. That does not mean that you will be able to just do these problems by watching this video for the first time. You need to really understand and know the rules and know what you're doing to be able to pass this midterm. So just trying to help you prepare to be successful in the course and on the midterm. All right, so one of the first problems you can expect to see is a problem like number 1 here. This is from section 1.3. So I did put at the end of each problem what section it comes from. That way, if you want to go study that section more, you can. And this problem says to use the properties of exponents to simplify the following expression, writing your answer with only positive exponents. So In math, we don't want to have any negative exponents in our answers. And then also we just want to try and simplify as much as we can to get the most simplified version of the problem that they're giving us, the expression that they're giving us. So in this problem, the first thing there's a couple ways you can start, but the first thing I'm going to start with is this exponent of 4 that is being raised to everything in those parentheses. And I know that because it's on the outside of the parentheses. So on that formula sheet, I'm going to give you all the exponent rules, but you should have seen them by now at this point in the course. So I'm not going to list them all out here, but I will tell you which one I am using. So for that first one, I will be using the product to a power rule. And that is when you have multiple things being multiplied by each other, and then it's all raised to an exponent like this. So because all of those are sitting next to each other, they're being multiplied on the inside. And then that exponent of 4 is on the outside, so all of that is being raised. So that rule tells us that if I do have a product of 2 or more things here being raised to an exponent of m, that I can give every factor in that product the exponent. So this would be a to the m times b to the m power. Okay, so to use that first rule, I'm going to copy down the numerator just as is, 3 to the negative 5th power, over. Then the first product in that, or factor in that product, is 3 to the negative 2 power. So 3 to the negative 2 power will get the exponent of 4. Y to the 4th power will get the exponent of 4. And x squared will get the exponent of 4. So I give everything in that product that exponent. Okay, so then the next rule I'm going to use is, and let me highlight these so you see what I'm doing, is the power to a power rule, because all of these here have an exponent and then it's being raised to another exponent. So for example, y to the 4th power being raised to another power of 4. So that is called the power to a power rule. And that says that if I have x to the n power and then I raise it to another power, that I multiply those two powers together. So this would be x to the n times m power. So I'm going to use that rule on all 3 of these because they all 3 have power to a power. So I will bring down my numerator, 3 to the negative 5th power. So on the bottom here, 3 to the negative 2 power raised to the 4th power. Well, using that rule, I would do the negative 2 times 4. And so that will give me 3 to the negative 8 power. The next one will be y to the 4 times 4 power, which would be y to the 16th power. And then the last one would be x squared to the 4th power, which would be x to the 8th power, because 2 times 4 is 8. So that is me multiplying all of those powers together. Okay, and then finally, the last thing I would do, what I would do now is get rid of my negative exponents, because, and the rule for negative exponents tell us that, just write negative exponent. If I do have x to the negative n power, that I can flip this upside down in a fraction, and since this doesn't have anything, I could put it over 1. So this would be 1 over x, and then it changes the exponent to a positive exponent. And it also works if the negative exponent's on the bottom, I can move it to the top and multiply by what's up here, which is just 1. So that would just be x to the positive n power. So when you have a fraction like this, all you need to do is, if you have a negative exponent in the numerator, like we do here, then I'm going to bring that to the bottom of the fraction and make it positive. And if I have one in the denominator, like I do here, then I'm going to bring it to the numerator and make it positive. So I'm just really going to flip those two. So the 3 to the negative 8, I'm going to bring that up to the numerator and make it positive 8. And then on the bottom, the 3 to the negative 5th power will be brought to the bottom, and it'll change it to a positive 5. And then I'll copy everything else down. And then the last thing I'm going to do is combine these two, because that has the same basis. Both of those exponential expressions have the same base. So that is the dividing by like bases rule. And that rule says that if I have x to the m over x to the n, so both of these bases are the same, like those 3's are, then I keep the base and I take the numerator on top and I subtract, or the exponent on top, and I subtract the exponent on the bottom. So that would be equal to x to the m minus n power. So 3 to the 8th power over 3 to the 5th power is 3 to the 8 minus 5 power, which is 3 cubed. And because this is a positive exponent that I got, that will stay on top. So this will be equal to 3 cubed over y to the 16th times x to the 8th, because I've combined those two exponential expressions. So it's no longer in the denominator. And finally, I can actually evaluate 3 cubed. 3 cubed is 3 times 3 times 3, which is 27. So the final answer, maybe I can move this. Final answer is 27 over y to the 16th times x to the 8th power. There's nothing else I can do. I don't have any other like bases, no other negative exponents, so that's the final answer. All right, so that's section 1.3. Number 2 is from section 1.6. So this section was all about factoring. Now, I didn't even really need to include this section, but I did so that you would have a review of factoring. But that intermediate algebra class that you take before this class, or if you didn't take it, then you should have learned it in high school, is all about factoring. So You are supposed to know how to factor for this class already, but I included it so you could have a refresher. So hopefully you read the text there and watched the videos. But there are many ways to factor, and it really depends on the form of the expression that you're given to factor. So number 2 says factor the following polynomial by grouping. So at least it is telling me which technique to use. And if it cannot be factored, you can click that it cannot be factored. It's not factorable. Okay, now first thing I want to say is this is just an expression. There's no equal sign. So I'm not trying to solve for anything. I'm just trying to factor it. And factoring means to write it as a product of 2 or more expressions. So right now, this is a sum and difference of terms, but they want me to factor it into a product of expressions. So there's 4 terms here, and anytime there's 4 terms, you always want to try to factor by grouping first, because that's the main method that's used for a 4-term expression. Now you could also always try and see if there's a common factor in all 4 terms, but there's not. There's nothing I can factor out of all 4 of those terms. So I'm going to continue with factoring by grouping. So factoring by grouping, the first step is to group together the first 2 terms and then group together the second 2 terms. And you can either include this sign. Usually if it's plus right there, then you don't have to include it in the parentheses, but I do just to show you, because if it's negative, you want to pull out the negative there. So if the second group starts with a negative, you would want to factor out a negative from that group, always. So step 1 is to group the terms. So you group the first 2 terms, and then you group the second 2 terms using parentheses. Step 2 is to factor out GCF from each group separately. So you look at these 2 terms and say, what's the GCF? What do they have in common? Well, both of those terms have a factor of y in common. So the GCF is y. That is their greatest common factor. So I'm going to pull out the common factor of y and multiply by what's left after I divide both of those by y. So that'll leave me with a minus 3b. The second group has a factor of 3 and x. They both have an x in both of those terms, and they both have a factor of 3 because 3 can be divided by 3 and 9 can be divided by 3. So the GCF here is 3 times x. And I'm going to pull out a positive 3 times x, so I would write plus 3x out here. You always want to include the sign. And multiply by what's left after I divide both of these by 3x. So if I divide 3ax by 3x, that'll leave me with just a. And if I divide negative 9bx by 3x, that'll leave me with negative 3b. So you can see that these 2 match each other, and they should. When you factor by grouping, these 2 factors should match each other, or you did something wrong. So step 3 is to factor out the GCF from both terms. And the GCF will be the factor that matches. So let me use that color there. That is your GCF. Both of these terms have a minus 3b in common. So I'm going to pull out the a minus 3b, and it gets multiplied by what's left on the outside, which is y plus 3x. So that is the final answer. This is factored because it is a product of two expressions. It's no longer a sum or difference of terms. Okay. Next problem says to factor the polynomial by factoring out the greatest common factor. So this is kind of similar to that last step we just did. A term is just a can be a product of two things. So over here, since this is 7 times all of that, this is actually one term. And you can think of this first one as 1 times all of that. So that could also be considered one term. Anytime there's not a number in front of it, you can consider it to be a 1 being multiplied by there, because that's anything times 1 is itself. So the GCF here in those two terms is the a minus b to the 6th power. So if I pull that GCF out, it gets multiplied by what's left on the outside, which would be 1 plus 7, which is just 6. So this would be a minus b to the 6th power times 6. 1 plus 7 is 8, not 6. And this could also be written with the 8 in front. It doesn't matter. The 8 could just be written in front. But because they want it factored, you'd want to leave it like this. Don't distribute that 8. Just leave it like that. This is the factored form. Okay. Okay, number 4 says to factor the following trinomial. If it cannot be factored, indicate not factorable. So far, this one told us to do factoring by grouping. The other one was just factoring out a GCF, which you can always try to do with any expression. But this one is a trinomial, which means 3 terms. And we have a y squared and a y and then a constant. So this is actually the form of a quadratic. This is a quadratic trinomial. The general form of a quadratic is ax squared plus bx plus c. Of course, x can be any unknown variable. In this case, it's y. So to factor a quadratic in this form, the first step is this is called the AC method sometimes. So if you Google that, There's tons of videos on factoring using the AC method, and that's how you have to factor a quadratic of this form. Okay, so step 1 is to multiply A times C. So in this case, the A, which is the coefficient in front of the variable squared, so this would be 12, times C, which is the constant at the end, which would be 15. So we need to multiply 12 times 15, and that's going to give us 180. Oops. So that's step 1. Step 2 is to find two numbers that multiply to give you that A times C, which is 180. But they also need to add to give you the B, which is negative 29 there. That's the coefficient in front of the X term. So it needs to equal negative 29. Now these are big numbers, which is fine. But it can take a little bit more time to figure out what two numbers to use. But the best way to do this is to start listing out factors of 180. So you can just texting my husband back. Okay. So you can just start dividing 180 by numbers to find two factors. So dividing it by 2 will be too far apart. 180 divided by 2 is 90. So that's 2 times 90. There's no way that's going to add up to negative 29. 180 divided by 3 is 3 and 60. That's also not going to work. 180 divided by 4 is 45. That's not going to work. 180 divided by 5, that's not going to work. Well, that's 5 and 36, so that almost works actually, but the signs have to match. So they both have to be either negative or positive to equal a positive 180 when you multiply them. So we need to keep going. 180 divided by 6 is 30. So that's not going to work. And 180 divided by 9 is the next one I'm going to do. So 180 divided by 9 is 20. So that's 9 and 20. So that one, that pair is the pair that will work as long as they are both negative. So I need a negative 9 and a negative 20. Because negative 9 times negative 20 is a positive 180. And negative 9 plus negative 20 is negative 29. So those are the two numbers that work. So you may have been able to find that quicker than me, but I was just going through the process of what it takes if you have no idea where to start. So you just start dividing that number by numbers to see if you can find a pair of factors that could add up to the b. So I'm now going to erase this part so I have more room. Okay, so now step 3 is going to be to replace the middle term using the two numbers we just found. So the middle term is this negative 29y. So instead of negative 29y, I'm going to write this as 12y squared minus 9y minus 20y plus 15. So I replaced this middle term here with negative 9y minus 20y. So I use the coefficients with the I use the numbers we found here as the coefficients for the y, because negative 9y minus 20y is negative 29y. So I just replaced that middle term. I rewrote it. So the last step is to factor by grouping. So we've just done that. So I'm not going to spend a lot of time on that. So you group together the first two, group together the second two, and you factor out a GCF. So for the first two terms, the GCF would be 3y. And if I divide those two terms by 3y, I'm left with 4y minus 3. The second two terms starts with a negative right there, so I have to pull out a negative factor. And 20y and 15 both have a factor of 5, so my GCF would be negative 5. And then that would be multiplied by positive 4y minus 3 after I divide both of those by negative 5. So notice that these match, which they should. Like I said, when you factor by grouping, those should match. So the final answer is the one that matches, 4y minus 3 times 3y minus 5, what's left on the outside. So that is the final answer. And again, they just wanted us to factor it, not solve an equation. So I would just leave it like that. Okay, number 5, this is moving into section 2.3 now. So section 1.6 was all about factoring techniques, and section 2.3 is all about using those factoring techniques to solve equations now. So now we see an equal sign. So they want me to solve this quadratic equation by factoring. So again, quadratic, I showed you the general form of a quadratic expression, ax squared plus bx plus c up there. Quadratic equation has the form ax squared plus bx plus c equals 0. Of course, it doesn't have to look exactly like this at first, like this one is not equal to 0, but I can get it equal to 0 by subtracting things from one side. The main thing that makes it quadratic is that there is one variable, x or y or whatever the variable is, and you have one squared and one not squared. That's what makes it quadratic. Okay, so, but of course it's telling us that, so that's fine. So you could have this on your flashcard if you needed to. You could write all of these steps for factoring that quadratic on your flashcard if you need to, but not with the numbers. You have to write it out in words to explain what to do. You can't use the examples like I did with the numbers. All right, so step one to solving a quadratic equation is to get it to look like this. This is step one, get it equal to 0. So I'm going to start subtracting terms from the right side. I'm going to subtract 8y squared over here with the like term, and that'll cancel there. I'm going to subtract 42y with its like term over there, and it'll cancel here. And then the minus 23, since that's negative, I need to add 23 to cancel it there. Always the opposite sign. So I add 23 to the left side. So on the right side, this will now be equal to 0. And on the left side, 9y squared minus 8y squared is just 1y squared. 26 minus 42 is negative 16, so that would be negative 16y. And 40 plus 23 is 63. Okay. So I have gotten it equal to 0, which was step one. Now step two, I'm going to factor the left side. Now, this is a quadratic, but a here is equal to 1. So when a is equal to 1, it's actually, the process is a lot easier. You know, technically you could still follow this process I went over up here, but it is a lot more steps when a is not equal to 1, because here a was 12. So we had to do all of those extra steps. But when a is equal to 1, it's a lot easier. So first step is to find two factors that multiply to give you c, which is 63 in this case, because that's my constant at the end. And then they also need to add to give me my b, which is negative 16. And I know that 63 is equal to 6 times 9. Or, I'm sorry, I meant 7 times 9. And both of these would need to be negative to make the signs work. Negative 7 times 9, or sorry, negative 7 times negative 9 is a positive 63. Negative 7 minus 9 is negative 16. So those are our two numbers. Now what makes this easier is that I don't have to replace the middle term here with my two numbers and then factor by grouping. When a is equal to 1, you can just go straight to this factor, put your variable, which is y, and then fill in the numbers that you just found, negative 7 and negative 9. So that is what this factors to. Y minus 7 times y minus 9. Of course, you could FOIL this out, multiply it out, and check. But that is the factored version of that quadratic. So you can always do that as long as a is equal to 1. If a is not equal to 1, then you have to do what we did in the previous problem. Okay, so now this is factored completely, but what we're trying to do is actually solve this equation. So I need to now set each factor equal to 0. and solve for y. This is called the zero product property. So anytime you have two things being multiplied and it's supposed to equal 0, we're trying to find the solution. What makes this true? Well, if something makes the first factor 0, then 0 times whatever this is 0. So that would be true. And same thing with the second factor. So all I need to do is take both of these factors, y minus 7, and then the y minus 9, and set them equal to 0. So y minus 7 equals 0, or y minus 9 equals 0. And then I solve both of these equations separately. So I add 7 to both sides, so y equals 7 is one answer. And I add 9 to both sides to the other equation, so y equals 9. And those are the two answers. Of course, you could always plug them back in to the original to check. Okay, so that's always your goal when you're trying to solve a quadratic equation. You want to get it factored, and then you want to set the factors equal to 0 and solve each one separately to get your answers. Okay, number 6. Solve the following quadratic equation by factoring. If needed, write your answer as a fraction reduced to lowest terms. So we're still in section 2.3. Okay, now this one is actually, there's two ways you can solve this equation, but I'm just going to do what it says and do it by factoring. So this quadratic is actually a special case quadratic, and it is in the form, it's called a difference of two squares. And that takes the form a squared minus b squared. That's what this is. All of this is something that can be rewritten as something squared minus, and then 64 can be written as a number squared. And when I have something in that form, this factors to a plus b times a minus b. So this is actually a formula that you can have on your flashcard. So what do I mean by it can be something squared? So 100 is equal to 10 times 10. And z squared is equal to z times z. So this could be rewritten as 10z all squared. Because if I multiply that by itself, it will give me 100z squared. Minus, and then 64 is equal to 8 squared. So now comparing that, let me bring down my equal 0 so I don't forget that this is an equation I'm trying to solve. The a is whatever's being squared in the first term, which is 10z. And the b is whatever's being squared in the second term, which is 8. So filling that in, let me just write that. A here would be 10z, and b would be 8. So now plugging that in for a and b here, this would factor to 10z plus 8 times 10z minus 8 equals 0. So that's how that factors. Okay, so now that we have it factored, we will set each factor equal to 0, just like we did in the previous problem. So set this equal to 0, and that factor equal to 0. So this would be 10z plus 8 is equal to 0, or 10z minus 8 is equal to 0. So to solve the first one, I want to subtract 8 from both sides, because my goal is to get the variable by itself. So I want to get rid of the positive 8. So this would leave me with 10z equals negative 8. Make some stuff smaller here. And then divide both sides by 10 to get rid of the 10. So z would be equal to negative 8 over 10, but that reduces to negative 4/5 because both of those can be divided by 2. So that's one answer. And then on the other problem, I need to add 8 because it's being subtracted there. Both sides. So that will leave me 10z is equal to 8. And then divide both sides by 10. So this would be equal to positive 4/5. So those are my two answers for that problem. Okay. So again, there is a lot of different techniques that are used to factor, and it's all about knowing and being aware of the particular form that you're trying to factor. Okay, number 7, still in section 2.3 here. Solve the following quadratic equation by factoring. If needed, write your answer as a fraction reduced to lowest terms. So this one is a quadratic, but you can see that it doesn't have a constant. It's more this form here, ax squared plus bx equals 0. There's no plus c right here. So when that's the case, you're going to factor out a GCF. That's the technique you're going to use, because both of these terms have a common factor of x automatically. They both have the variable x. They also have a common factor in the numbers, which would be 3. So the GCF is 3x here. So I'm going to pull out 3x, and that will leave me with 1x, since I had 2 to start with, and now there's only 1. Or I had 2 to start with, and I pulled out 1, so there's 1 left. And then 12 divided by 3 is 4, so that would be just plus 4, because I took the x, and then you take the factor of 3 from 12, which leaves you with a factor of 4, because 12 divided by 3 is 4. So this is now factored. It's a product of two expressions. So same thing, after I factor it, to solve the equation, I take each of these factors and set them equal to 0. So I have 3x is equal to 0, or x plus 4 is equal to 0. So on the first one, you can divide both sides by 3 to get rid of the 3, and x would just be equal to 0, because 0 divided by anything is still 0. The next one, you have to subtract 4 to both sides, so x would be equal to negative 4, and that would be your answer. And again, you can plug both of these numbers back in for x here to check your answer. So when you take the midterm, you can see if you did it right. But those are the correct answers. Okay, so that's a little hint there. If you don't have a C and it asks you to solve by factoring, just factor out the GCF. And then set each factor equal to 0 always. Okay, number 8, solve the following quadratic equation by using the quadratic formula. So if you remember, The quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All of that's divided by 2a. This is the quadratic formula, so you would definitely want to have that on your flashcard. And this formula gives us the solution to quadratic equations that are in this form. Ax squared plus bx plus c is equal to 0. But it has to be equal to 0 first. Okay, so that's always the first step. That's called standard form when it's equal to 0. It's the standard form of a quadratic. So that's what we're going to do first. Step 1. Get in standard form. Okay, and we're going to do that by adding that 41 to both sides so that it'll cancel on the right. And that will give us 0 on the right. So that leaves me with y squared plus 8y plus 41 is equal to 0. Okay, now you could try to factor this, but it's not factorable. This can't be factored. So the only way to solve it is by using the quadratic formula. So you can always use the quadratic formula, even if it's asking you to factor. But sometimes you have to use it. And this question will tell you to use it anyway, so it'll give you a little hint. But we need to know what our a, b, and c is, so we can plug it into that formula. So a is equal to 1, because there's nothing being multiplied in front of that y squared, so that's just understood to be 1. B is 8, that's what's being multiplied by the y, and the constant at the end is 41. So I'm going to plug in this a, b, and c into my quadratic formula. Okay, so our solution, I'm going to start over here, would be negative b, which should be negative 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times 1 times 41, because that is our c, all divided by 2 times a, which is 1, so just 2. Okay, and then we're just going to start simplifying. So you want to start underneath the radical first. So I'm going to bring down the negative 8 plus or minus. 8 squared is 64. And negative 4, where did my calculator go? Negative 4 times 41 is negative 164. So the next thing I would do is simplify the 64 minus 164. And that gave me negative 100 all over 2. So when you have, at this point, I've simplified everything under the radical. So now I want to simplify the radical. I'm just going to put simplified because that's just what we're doing here, simplifying. but specifically now I'm on to simplifying the radical. So first of all, if that was just the square root of 100, that would just be 10, because 10 times 10 is 100. But because there's a negative under there, remember that the square root of -1 is equal to I, which is an imaginary number. So we learned about those in section 1.8 in our complex numbers. So anytime you see a negative underneath the square root, you need to simplify that and rewrite it in terms of I. So this would be -8 plus or minus 10I, because the square root of 100 is 10, and the square root of the -1 is I. And this is all over 2. And now I can simplify by dividing everything by 2. Only because everything can now be divided by 2, though. So -8 divided by 2 is -4. Plus or minus 5I. And then over 1. So just be like that. Now notice this is 2 answers. It's technically -4 plus 5I. And -4 minus 5I. So there's 2 answers because of that plus or minus, but you know, if you put this in as your answer, I would accept it. Okay. So that would be the final answer. Okay, number 9, moving on to the complex numbers of section 1.8. So there's going to be some simple arithmetic here.